Assalamualaikum warahmatullahi wabarakatuh. We are from group number 8 and now we are going to presenting our slide with the title Performance Analysis or CDMA System with and Detection Technique using either NRZ or RZ as the modulation format at the encoder.
Good morning to Professor Said. I'm Niranjana Ramasamy and my metric number is 1712317742. I would like to present about our mini project, start from the abstract. Basically our project is based on optical CDMA or CDMA with end detection technique and analyze the system performance of RZ or NRZ modulation. In order to do so, we used a software called OptiSystem.
Good morning, sir. My name is Tarishini Ravisegar. My metric ID is 171231755. Today, I would like to talk about introduction about our mini project. OCDMA is capable of offering a low-cost components, all optical processing, simplified network control, efficient bandwidth allocation, and privacy in its communication. First of all, in OCDMA system, the detection process affect the design of receiver and transmitter. Basically, there are two types of detection technique, coherent and incoherent. The coherent detection technique refers to detection signal with knowledge of phase information of the carrier, while incoherent detection technique is reversely from coherent detection technique. By referring to coherent detection technique, this technique does not need phase synchronization. Therefore, it will reduce hardware complexity of the system. Next, in this project, end detection technique is developed to suppress the effects of both PIIN and MAI effectively in incoherent OCDMA system. And detection techniques actually provide much better performance compared to other detection technique. And of course, end detection technique is considered as the best solution. Other than that, data formatting is one of the important issue in the design of optical communication. The common optical pulse generators that employed for data formatting are NRZ and RZ. Finally, MWDW codes are utilized as the signature codes for OCDMA system. The system has been simulated using OptiSystem commercial software for 3 simultaneous channels, taking into account the effect of fiber non-linearities, dispersion, attenuation, receiver thermal noise, and dark current short noise. Thank you, sir. That's all from me for introduction.
Hi, my name is Farida binti Ibrahim with my metric number 171231705, and I will continue for simulation setup part. As we can see here, at the transmitter side we use two channels, and each channel has two optical sources with different frequency range, and we combine them using a multiplexer and direct connect to Mach-Zehnder external modulator. For each channel, we use a different pulse generator, where the first channel we use RZ pulse generator and the second channel we use NRZ pulse generator. To measure the performance of optical spectrum, we use optical spectrum analyzer, and we combine the channel, use a power combiner. From a power combiner, it will directly connected to a single optical fiber where the wavelength is 1550 nanometer, and for the distance we consider from 40 km to 80 km because we want to measure the maximum of optical fiber can go through. At the receiver side, we use power splitter to split back the channel and then connect it to rectangle optical filter, where each rectangle optical filter use different frequency and bandwidth. We also use a pin photo detector, and for N subtraction technique, we use electrical subtractor component to subtract the overlapping data and to filter out the unwanted noise that comes from optical fiber, we use low pass Besser filter. And lastly, to measure the performance of BER, we use BER analyzer, and for the bit rate, we use 2.5 gigabit per second. And we also measure the performance in terms of input laser power from 0 dBm to 10 dBm. That's it for simulation setup.
Good morning again to Professor Said. I'm Niranjana and my metric number is 1712317442. Now I would like to present on the two type of modulation. So what is RZ? RZ, also known as return to zero, in which power is transmitted only for a fraction of the bit period, and each optical pulse representing one bit is chosen to be shorter than the bit slot, and its amplitude returns zero before the bit duration is over. Next is NRZ, non-return to zero, defined in which constant power is transmitted during the entire bit period, and the optical pulse representing each one bit occupies the entire bit slot and does not drop to zero between two or more successive 1 bit. One of the advantage of NRZ modulation is it is in smaller bandwidth for transmission and non-sensitive to laser phase noise. Here we can see the sample BER analyzer using the RZ modulation format at an input power of 0.001 watt. From this, it can be analyzed that the Q factor of this RZ modulation is 17.11, and the height of I diagram is 0.00022, and the BER, which is bit error rate, is 4.24 exponential of negative 66. And this diagram represent of BER analyzer also, but using NRZ modulation technique at an input power of 0.01 watt, same as we used in RZ modulation. From this diagram, we can see that the Q factor is 70.144. Height of the eye is 0.0031, and the BER is decreased to 0. Based on the analysis, it can be said the higher the input power, the higher the Q factor and the BER. And it can be concluded that the result of NRZ modulator is better compared to those obtained for RZ modulation technique.
Assalamualaikum warahmatullahi wabarakatuh and good day to Prof. Said. My name is Nur Fatiha binti Muhammad Anwar Ali and I am from RK93. My metric number is 1712327771. Now I will continue with the performance analysis. As you can see, there are two figures. So from the left side is the figures of encoded spectrum code 1011 with the RZ, and on the right side is the figure of encoded spectrum code 2110 with the NRZ. Alright, so for the next slide, as you can see, this is the figure shows the combined spectrum inside the fiber core. So from this figure, from this spectrum, I conclude that the increase of the power can be observed at the last chip due to the overlapping of the chips from the two codes. So the multiple access interference will degrade the system performance due to this overlapping spectrum. So that is why this spectrum had been formed.
Hello and Assalamualaikum. My name is Nur Azira Mida Azman from RK93. My number matric is 1712311747. And I will continue to explain about the result part. For the first simulation, we observe the BER by changing the input power with a same distance. And as you can see here in the table, we put that when the input power is 0 dBm, the RZ modulation is 2.33 e to the power of negative 19, while for the NRZ modulation, we get 1.90 e to the power of negative 28. For the 2 dBm input power, we get 2.42 e to the power of negative 44 for RZ modulation, while for NRZ modulation, we get 1.08 e to the power of negative 36. In the graph, as you can see, when increase the power, input power, we get the decrease the value of BER. But at the some point, like when in RZ modulation format, we get it remains 0 when input power is 8 and above. While for NRZ for modulation format, the BER will remain 0 after the input power is 6 dBm above. For the next simulation, we observe the bit error rate by changing the distance with a same input power. We change the distance by 40 km, 50 km, 60 km, 70 km and 80 km. For the bit error rate, when we using the RZ modulation format, for 40 km distance, we get 0.12 e to the power of negative 240. While for an RZ format, we get 0.27 e to the power of negative 155. For 50 km, we get the RZ modulation is 0.18 e to the power of 118, while the NRZ modulation format, we get 5.06 e to the power of negative 63. And so on, as you can see in the table. As you can see at the graph, we can see that when increase the distance in kilometer, the value of BER is increased. For the NRZ modulation format and also for the RZ modulation format. And that's all for me. Thank you.
A very good morning, sir. My name is Parmeshwari Armugam. My metric number is 1712311752. Here I'm going to present the conclusion of our mini project. This project is demonstrated that the BER versus input power. BER is a bit error ratio versus input power. So the result shows the RZ as a wider optical bandwidth than NRZ path. Secondly, BER versus distance. It shows that BER is increased as well as when the distance is increases. Finally, the output performance is measured in terms of BER. While the SNR increase with the signal, it will be normal for BER to decrease with the transmitter power level. That's all. Thank you.